Good morning, IB Math. Moving on in Chapter 6, here we come to about the midpoint, Section L, which deals with the sum and the difference angle trigonometric identities. The textbook is a little bit stingy. It gives you one and proves it, and then it leaves you for exercises to prove the other ones. I'm going to give you all of them, but then we'll look at the proofs of some of them and how we use them. A lot going on here. Again, if you've had the pre-calc, you've seen a lot of these before, but it still can be kind of tricky the way that the IB looks at these things. Before we get into sum and difference, we really need to know our unit circle very well. If you haven't done the lessons that I posted about the unit circle, make sure you do those before this lesson. Go back, print off a unit circle, or if you can't print, draw one, make a nice unit circle with all the information in it. You will need that information. You do need to know your unit circle. You're expected to know it. IB just assumes you've done it in a previous class, that you know it and you can use it. Now with that in mind, I do want to take a closer look at 4 different angles. These are special angles from our special right triangles. I want to look at a 30-degree angle. Oh, that pen's about there. A 30-degree angle, which would be here. And I know the ratios in a 30-degree angle. If this side would be 1 and 2 and root 3. I want to look at a 45-degree angle. And I know my ratios are 1, 1 and root 2. A 60-degree angle. 1, 2, and root 3, and then a 90-degree angle. And I'm going to put a diagram in here a little bit later, and we'll talk about how would I do a 90-degree angle. So I want to take a closer look, and I want to answer the questions: what's the sine of 30, the cosine of 30, and the tangent of 30? And these we're expected to know. Again, the IB assumes that you had a trig class in your previous class and you've done the trig here. We know that sine is opposite over hypotenuse. So the sine of 30 is 1/2. Cosine adjacent over hypotenuse, root 3 over 2. The tangent opposite over adjacent, 1 over root 3. Oh, excuse me. And of course, we would rationalize the denominator here. I think root 3 over 3 would be a better answer. How about the sine of 45, the cosine of 45, and the tangent of 45? Sine is opposite over hypotenuse, 1 over root 2. And I think root 2 over 2 would be better. Cosine adjacent over hypotenuse, again 1 over root 2. Rationalize the denominator, root 2 over 2 would be better. Tangent opposite over adjacent, 1 over 1, which is 1. And then 60 degrees, the sine of 60, cosine of 60, and the tangent of 60. Sine is opposite over hypotenuse, root 3 over 2, cosine adjacent over hypotenuse, tangent opposite over adjacent. Now what about 90 degrees? Well, for 90 degrees, I want you to think about it as a little bit differently. For 90 degrees, I want you to think about it as a unit circle here. This 90 degrees, that's the point right there. That's a 90-degree angle. So if I ask what's the sine of 90, cosine of 90, and the tangent of 90, the sine is really just the y value there. So the sine, the coordinates of this point are 0, 1. So the y value, the sine is 1. The cosine is 0. The tangent is opposite over adjacent, is the y value over the x value. So it would be 1 over 0, so the tangent would be undefined. All right, so we need to know these angles, and we're going to use these angles in our formulas. All right, so let's take a look at the identities, the sum and difference. Now, as I said, the textbook, the exercises 1, 2, and 3, and 4, 1, 2, and 3, and a couple of the other ones are all about finding all of these identities on your own. I think that's a little bit pedantic, so I'm going to give them to you, but we will work backwards and see how to find them, because I suspect that IB will definitely do some of these on their tests. So here are the sum and difference identities. The sine of two angles being added together, and I'm going to call the angles U and V. So the sine of two angles being added together is the sine of U times the cosine of V plus the cosine of U times the sine of V. The difference, the sine of U minus V, two angles being subtracted, is the sine of U times the cosine of V minus the cosine of U sine of V. Usually that one's not so bad to memorize, but it gets confusing as we start adding all of the other identities. Let's take a look at the cosine of the sum of two angles. The cosine of U plus V is the cosine of U times the cosine of V minus the sine of U, the sine of V. The cosine of the difference of two angles, U minus V, is cosine U, cosine V, plus sine U, sine V. Tangent gets a little bit weirder. The tangent of a sum of two angles is the tangent of U plus the tangent of V divided by 1 minus the tangent of U times the tangent of V. Very similarly, the tangent of a difference between two angles is given as the tangent of U minus the tangent of V over 1 plus tangent U tangent V. So here they are. Here's all the identities. Write these down. Have these identities nearby. You're going to need them, plus your unit circle. What I would do is I would start creating or using your formula booklet or creating a piece of paper, unit circle, with all these different identities that you can use for assignments. Know what's in your formula book and what you're going to be given and what you don't have. All right, so that's the notes. Now let's look at the application. And you know that's always the hardest part about the IB problems is the application. So let's look at doing some sample problems here. So for example, so problem 1 is going to ask you to replace in the sum formula to find the difference formula. Problem 2 is going to ask you to do the same thing. 3, given the fact that tangent is sine over cosine, substituting it in and following it through. We might want to do that one. Let's take a look. I know that the tangent of theta is the sine over the cosine. Okay, so if I do the tangent of A plus B, doesn't that make sense that it would be the sine of A plus B over the cosine of A plus B? All right, well, can I prove this? Well, let's see what happens here. The sine of A plus B, and again, I'm going to use my formula sheet. Make sure you've got that formula sheet handy. I know the sine of A plus B is going to be the sine of A, the cosine of B, plus the cosine of A, the sine of B, all over the cosine of A plus B is cosine A, cosine B, plus sine A, sine B. So now as I look at this, clearly there doesn't seem to be anything that I can factor here. If I take a look at this formula, and I want to simplify this here, if I multiply, and what I really want to do is multiply by the conjugate of the denominator over itself. Cosine A, cosine B minus sine A sine B over itself, multiply out the top, multiply out the bottom, get common denominators, and you will get the tangent formula. Okay, so it's all about substituting in to find the formula. That's the idea. Substitute it in and then kind of follow it, and you'll find the different formulas there. The real the textbook loves having us work and find all these formulas and prove all these formulas. Just know them. Most of them are in the formula book, so although we might see it on a test, the formula's already there. You're just trying to verify that it is indeed true. But let's take a look at where the application really lies here. Suppose I want to evaluate something like the cosine of 75 degrees. Now, 75 degrees is not one of our nice, well-behaved unit circle angles. So it doesn't seem like I can do it off the top of my head. Now, pre-calc students, you're already out there screaming. You know exactly what's going to happen, because I can rewrite 75 as 45 plus 30. I can take an angle that I don't know and rewrite it as the sum of two angles that I do know. And using my sum formula, the cosine of u plus v is equal to cosine u cosine v minus sine u sine v. Therefore, the cosine of 45 plus 30 equals the cosine of 45, the cosine of 30, minus the sine of 45, the sine of 30. These are all degrees. I'm getting lazy with my degree marks. And I should know each of these. They all come from the unit circle, or the activity that we did at the start of class. What's the cosine at 45 degrees? 1 over root 2. The cosine at 30 degrees? Root 3 over 2. What's the sine at 45 degrees? 1 over root 2. And the sine at 30 degrees is 1/2. Simplifying, I'm going to get root 3 over 2 root 2 minus 1 over 2 root 2. I get root 3 minus 1 over 2 root 2. And again, I know this is in bad form, and we really should multiply by root 2 over root 2 so that we rationalize the denominator. But I'm okay if you leave it like that. For this one, I'm okay if you leave it like that. All right, let's do another one. This one's kind of a weird one. What if I had something like the sine of 64 degrees times the cosine of 4 degrees minus the cosine of 64 degrees times the sine of 4 degrees. How could we evaluate that without a calculator? And again, the emphasis here is this would definitely be a non-calculator part. Well, I'm looking at this, and I'm thinking about this as the sine of u cosine of v minus cosine u sine v, where 64 is the u and 4 is the v. What identity is that? If I look back at my identities, sine u cosine v minus cosine u sine v, that's the sine difference. This is the sine of u minus v. There's the identity. What's the u? What's the v? So therefore, this becomes the sine of 64 minus 4, which is the sine of 60, and we know the sine of 60. The sine of 60 is root 3 over 2. So this original problem looks ridiculous. I mean, how on earth would you do something without a calculator? It's all about the sum and difference identities, recognizing which sum and or difference identity it is. All right, let's take a look at another sample problem here. Slightly different way of doing this one. Suppose I tell you that I'm going to give you that angle A is acute, and the sine of angle A is 3/5. Angle B, however, is obtuse. And the sine of angle B is 5/13. And I want you to find the cosine of A plus B. All right, so we have to be a little bit careful here. Don't ignore this acute and obtuse thing. That's going to play an important role here in a moment. But I can expand this out, the cosine here, and if I expand the cosine formula out, I know that the cosine of U plus V is cosine U cosine V minus sine U sine V. And these are really A's and B's, aren't they? This is just A's and B's. So cosine A, cosine B minus sine A, sine B. Here's what I have to substitute in. Well, I know, what do I know? I know that the sine of A is 3/5, and the sine of B is 5/13. But do I know the cosines of these angles? It doesn't seem like I know the cosines of these angles. Well, I have to think about where are those angles. So what I'm going to do is I'm going to take a closer look at angle A. Angle A is acute and the sign is positive. That means it's in the first quadrant. Here's angle A. It's acute and it's positive. The sine is 3/5, opposite over hypotenuse, 3/5. So I can find the adjacent here is 4. Now I can do the cosine. What's the cosine of this angle? Adjacent over hypotenuse, it's 4/5. Now let's do the same thing with B. But B is obtuse. Sine is positive, but it's obtuse. That means it's going to be in the second quadrant. So here's angle B. Its sine is 5/13. The missing side here, Pythagorean theorem, we should recognize is a 12, but it's obtuse. It's a negative 12. Be careful, negative 12. That's why this part is so important. So now what's the cosine? Negative 12 over 13. All right, now let's simplify. Positive times a negative, negative 48 over 5 times 13 is 65, minus 15 over 65 gives me negative 48, 58, 63 over 65. There it is. There's my final answer. All right. So I just did sample problems like 1, 2, 3, 4, and 5. Let's do something like 6 where we have to prove an identity. So let's prove, let's see. Let's prove something like, you know what, let's actually do number D, which says that the tangent of A plus the cotangent of A is really just the secant of A times the cosecant of A. And remember, cosecant, they write it as C-O-S-E-C. That really gets on my nerves. C-O-S-E-C-A. They write it like that. This is acceptable. That's fine. They'll know what you mean. That's fine. So here we're going back to kind of verifying identities. And I have to pick a side and I work on it. So I pick the left-handed side or the right-handed side to work on it. I'm going to work on this side. Tangent, I really know, is the same thing as sine over cosine. Cotangent is cosine over sine. So I've rewritten tangent as sine over cosine, cotangent as cosine over sine. Now I can't move things back and forth because I'm trying to verify and prove the identity. I don't know it's equal, so I cannot use properties of equality. If I get a common denominator here, multiply by sine over sine, I get sine squared over sine cosine plus multiply this one by cosine over cosine, I get cosine squared over sine cosine. Got a common denominator, right? Combine them, and I get sine squared plus cosine squared over sine cosine. Ah, do you see? Did you spot this identity here? That's one of my Pythagorean identities. Sine squared plus cosine squared is 1. So I've got 1 over sine A cosine A, which is the same thing as 1 over sine times 1 over cosine. 1 over sine is really cosecant times secant. And what was it I was trying to prove? There it is. It's the same thing. We've proven it. Secant, cosecant, cosecant, secant multiplication is commutative. It doesn't matter which way around. I've verified the identity. I've proven that it was true by rewriting it and using the different identities. So you got a bunch of these in number 6. We just did one of them, so you got one less to do. And then number 7 is a little bit more difficult, where I've got the sum of 3 angles. And think about this. If I have the sine of A plus B plus C, couldn't I rewrite that as the sine of A plus B plus C? And then if I use my identity, the sine of U plus V is the sine of U, the cosine of V, plus cosine U sine V. So this becomes the sine of A times the cosine of B plus C plus the cosine of A times the sine. Oh, I can't write the argument in there. I hate using an extra piece of paper just for that, but it's important. The sine of V, which is B plus C. There we go. And then I could break this one up. The cosine formula, I can break that up. What would that be? And the sine, I could break that up. And then I'm going to have a whole bunch of different stuff there. And I can factor it and simplify it and cancel it and reduce it. So think about this as you're looking at problem number 7. All right, so this is the sum and difference identities. And a lot of times, number 6, the only ones I anticipate giving you a hard time is probably number 6, verifying different identities. And sometimes, you can spin out of control on these things. You just keep substituting things in, and it doesn't seem to be getting any simpler. It doesn't seem to be reducing, and it just becomes this big, complicated mess. And a lot of times, students will come in the next day saying, oh, I couldn't figure this one out, and they show me their work, and they say, well, where did I go wrong? And I look at it, and I'll be honest with you, very rarely can I figure out where they went wrong. A lot of times I just say, you know what, I hate to do this, but let's just cross it all off and start fresh, start from scratch. And what you did last time, do something different this time through. I know that's the way I do it. If I'm trying to verify an identity or simplify some sort of expression, if I start spinning out of control, then and I'm not getting any closer, I'm getting further away, then you know what, scrunch it up in the paper roll, throw it away, start fresh, start again. And I know you don't want to hear that, but honestly, that's the best way of doing it. All right, so that's assignment 6L. What I'd like you to do, I'm going to use the back of this paper, save a little room, is I want you to do homework 6L. It's going to be on page 404. Error, page not found. And I want you to do 1 through 7. Now, hang on a sec. I'm going to bring the book under here and talk about them. So here's the textbook. Here's the assignment. Let's take a look at this. Given that sine of A plus B is that, replace B with negative B and put negative B's in there and simplify it, and you will prove the identity for sine of A minus B. I've already given it to you. In the same way, cosine A and B, plug in negative B and prove the formula for cosine of A minus B. And again, I've already given that to you. Gives you a little hint there. Number 3, given the identity implies this, show that is the same thing as this. We started this one, and then I told you multiply by a conjugate over the conjugate, keep going, and you will end up with that when you get common denominators. And then using this, plug negative B in there to to find the identity, and I gave you the identity here as well. Evaluating, we want to rewrite these angles that we don't know as two angles that we do know. And C and D, we did ones very similar to that as well, work backwards from there. Number 5, A is obtuse, B is acute. So what quadrants are those in? And careful, because the cosines and tangents might be negative. Number 6, identities. A, B, C, D, E, F, G, H, I, J. And we did one of these. I did one of them. I can't remember which one I did. But we did one of these and just kind of worked through them. And those are the ones where sometimes you can kind of spin out of control on them. For example, if I want to look at cosecant, there it is. I hate that, man. That just annoys me. Cosecant x minus sine is cosine times cotangent. Well, cosecant is 1 over sine. 1 over sine minus sine. Multiply that by sine over sine. And I get 1 over sine minus sine squared over sine. Combine them, right? And then I get 1 minus sine squared in the top, which is really cosine squared. And then simplify, and you will get the other side. And these ones, if you spin out of control, then start again. Ones like this, and I and J, and as I look at I and J, am I going to attack the left side or the right side? Here, if I'm going to attack this side, I'm going to multiply probably by the conjugate, 1 plus sine over 1 plus sine, and see what happens. If I'm going to attack this side, I'm going to rewrite these in cosines and sines, get a common denominator, and combine them. So I could do either or. Pick a side and work on it. If I was going to do this one, I multiply by 1 plus cosine over 1 plus cosine, see what happens, or maybe rewrite tangent as sine over cosine and see what happens. Or here, oh gosh, no, you know what? I don't think I would want to do a right-handed proof. I'm going to attack that side. Here's the one where I've got 3 angles. Remember, that's the same thing as A plus B plus C. And then when you've got the B plus C's, you can simplify those as well. All right, so there's the homework. Go ahead and get that done and email it to me. I appreciate those of you that are still working. A number of students have quit and given up and have ghosted me. About half the class, I'll be honest. If you're watching this, you are in the minority right now. But you will be much more prepared when classes start again in August, and we pick up from in Chapter 7. Those students that have ghosted me are going to have a lot of extra work that they're going to need to do to get caught up very fast in August. So I really do appreciate you guys still working. I'm getting tons of emails from you, and it's overwhelming, but it's overwhelming in a good way. Please be patient with me with the grading. I've run out of ink again printing them off, so I've decided I'm not going to print off any more of them. So that means I'm going to open them up and look at them one at a time, and then just grade it on my computer screen. And I've got a smaller computer screen. It's taking me a little bit longer to do it that way. But I'm not wasting a lot of ink, and I'm having some printer issues anyway, and I don't want to go to Walmart and buy another ink cartridge, man. Those suckers are expensive. But hey, keep working, guys. Keep working. I will keep doing these lessons and keep grading work, even if I'm only down to one last student in the class. As long as somebody's out there working, I will do everything I can. So really good on you for watching this lesson and working right now. Hang in there. We'll get through this. And we'll meet again, and we'll be in good shape, guys. All right, awesome. I will talk to you again soon. Bye.